Okay, hello everyone. Welcome back once again. All right. So today in section 8.4, we will be talking about the small sample test for population mean. So we've already talked about the last sample about what testing for the population mean. Okay, and now we are considering the small sample. It implies that our sample size is less than 30. In this scenario, we consider two test statistics. Either we use the Z or we use the T. We only use what? The Z if the population standard deviation is given. Okay, but if the population standard deviation is not given, if the population standard deviation is not given, then we use our what? Our T. That's it. And N is what? Is small. So we use this using something we call the degrees of freedom, N minus 1 degrees of freedom. Okay. And we've actually talked about how to determine the rejection region. So the rejection region is determined under HA or H1 based on the direction. If you have not equal to, then you have two directions. Okay, that is that. So we've already talked about something like this. So we are going to consider some examples. So with this example, our direction is to the left. And since we are using one direction, we use the whole of alpha. And our n is small, sigma is not known. So we use what? T. So for you to get your rejection region, we use the inverse T. So the inverse T will tell us, okay, what value should we pick for? So that we go to the left. So we are going to the left with no stopping. So we are going to the negative infinity. If it is to the right, we determine a value using the inverse T. Then we pick from that value to the right. So we are going to positive infinity. So that is what we did. So you use the inverse T to determine that. So you hit your in doing that, you hit on your second, you click on verse, then you are good to go. So let me demonstrate that for you to see. So you hit on your second verse, then you choose inverse T, okay, and you are good to go. So you enter your area, that is 0.01, then degrees of freedom, n is 26, subtract from 1 from it, and you are good to go. So this will help you determine your, so we pick from this point to the left based on the direction under the HA. Okay, that is what you do. You do the same. If it is two-sided, first of all, divide your alpha by 2, isn't it? Because either we go left or you go right. So divide your alpha by 2. Then you union your what? You union them. Okay, so just as I've actually underlined. So left and this is right. Okay, then we union what? These rejection regions together because they are two. All right. Okay, so and for question 3, we are going to the right. So we pick from a point, then we go to the right. With this question, we are just we've been given data. We've not been given the S bar out of it, raw data for us to actually perform our test. So anytime you hear about tests, the 5 steps you have to go through: state your null hypothesis, determine your distribution and the test statistics to use, then determine your rejection region, then you compare your test statistics with the rejection region, and you can also make what conclusion. So we've considered the critical value approach and the p-value approach. Any of them will give you the same what conclusion. So with this data, we input our data using what our stats. So if you go to the stats and you click on edit, it will help you input what? Your data. So after inputting that data, then the same stats, go to which test are you using? Okay, we are using T. So you hit on the T test. So here we have stats. If you click on the stats and start blinking, you're not going to see any list in it. But if you click on the data, then you're going to see a list. So you pull your data from the L1. Okay, then you specify your mu naught. So here mu naught is what? Is 0 because we are using something unbiased. So it's 0. Okay. So we use 0 and we pull our data from list 1. Then the frequency is 1. Then we choose which side are we going under your hypothesis. So you are going two-sided. Okay, so you choose on that for you to blink. Then you hit on your calculate, which will give you your T value, and so it's going to give you your T value and everything. So the T value that you see is T equal to 1 point. This is not the real data. I'm just demonstrating an example for you to see. Okay, and your degrees of freedom will now be n minus 1. Okay, so you need that to make a conclusion. Therefore, if you have your T value, you can actually compare it with your rejection region. So here we are under H, we are going two directions. are going two directions. So you determine the left, determine the right. Since we have the level of significance to be 1%, that is our alpha, we divide the 1% by what? 2 before we calculate our t. Okay, but in case you don't want to use the critical value approach, then you can hit the calculate, gives you the p-value as well. So the p-value that you see, so after t, you see what? P, that is your p-value, okay? And you compare your p-value to your alpha. So in case you can make conclusion from your p-value as well as the critical region, all of them gives you the same conclusion. Okay, so you don't need to calculate the critical region again, unless you've been asked to do so. But if not asked, you choose whether you are concluding with what? The p-value or the critical value approach. If you choose to draw it too, you're going to get the same value. All right, so note that this is not the right answer, it's just a demonstration. So the right answer based on the calculator is what you see here. Okay, all right. Please, if you are doing this and you're facing challenges, do well to email me and I'll be glad to help you with that. So we do say, so would the decision be the same at 5%? So you calculate your P, for now your P-value does not change. So your P-value, you compare it with what? Your alpha. So P-value compared with what? Alpha. And you realize that the decision does not actually what? Change based on the decision. 10%? No, because our P-value is 0.1475. Even at 10%, it doesn't still change. Okay, because so we still don't reject it. Okay, so we have similar example here as you can see. So in this example, although we've not been given, so out of the data, we've actually calculated everything for you. So you have a sample size of 5, so the degrees of freedom is what? Is 5. But let's check if standard deviation is given or sample standard deviation. So in this question, you've been given what? The standard deviation, so that is the sigma. Since you've been given sigma, although the sample size is small, but we are going to use the z, not what? The t, as you can see. So we don't use this, but we use what? Rather this. So you can go through the same approach using your calculator to get your z value based on the information that you have. Okay, so the population parameter, we assume it to be 8. That is the mu is 8. Okay, then we take a sample and calculate what? A mean out of that sample. So that will be your SB. Okay, so always the sample mean is calculated from the sample that we take. All right, but what we hypothesize first, we don't calculate it based on the sample. Okay, so that will be where your hypothesized value will be. So under H naught mu equal to 8, and HA mu equal to what? Mu not equal to what? 8. Okay. So you determine your rejection region either to use your p-value or to use, so here we have the p-value to be what? 0. If you compare this, if you are using the p-value to make a decision, you can compare it with what? The significance what? Level. So the significance level is what? 0.1. So that is what we have here. So p, so since p is less than that, then we reject what? Our null hypothesis. We reject H naught. And even the z, you can compare the z with any of these directions. So this is our z, the value here. You can compare it with all of these are rejection regions. So any that you compare it. But if you want to compare it with the positive, make z what? Positive. Realize that 5 falls within this region. Okay, so we still reject H naught. So the decisions will still remain the same. That is that. Please let me know in case you have any questions. So all these are, so in this scenario, we just want to know, are we using T or Z based on what the question is saying? Then we follow the same procedure, and that is what I've actually demonstrated. So all the examples that we are going to see is either Z or T. Okay, but we are changing from Z if the sigma is not known and the sample size is small. That is it. And it follows the same procedure. So if you are reviewing this and you don't understand anything, please do go to email me and I'll be glad to explain further. Because I want to keep it simple, I'm not going through all the examples. But if case you are going through and you still don't understand, please email me and I'll be glad to take you through one after the other. Thank you very much.